For those who do not know Airbus, I think we're the second largest aerospace company in the world. Most of you will probably know the commercial airlines. You probably have flown with it already. We do also helicopters, military combat aircraft, transport aircraft, UAVs, launcher systems, and satellites. And in brief, I would say we do everything which shall fly. We make it fly. I personally come from the combat aircraft area. And for the system, I want to look a little bit closer today. We have to zoom in and zoom even a little bit more. And it's the helmet the pilot is wearing. We call it HMD, as probably most of you know. And actually, it's a augmented reality system, and it's in use since decades. And it helps the pilot to get information about his aircraft, about how fast he's flying, how high he's flying, the direction he's flying to, the orientation of his aircraft, for example, but also to enhance his situational awareness of the tactical environment so that he knows where are his buddies, where are the foes, how far are they away, what kind of weapons are coming in, is he targeted maybe. And last but not least, the HMD is used to cue weapon systems of his own aircraft. And as mentioned, I'm coming from the simulation domain, so we do training and development simulation. And for flight simulator, we have some issues. How to use such a system in a flight simulator. So, of course, we could use the original hardware, but it's expensive. I mean, it's super expensive. It's more expensive than the rest of the simulator, so it's really only for the high-end stuff. It's very complex. It's a piece of avionic hardware and software, and which makes it hard. So we have aircraft buses in the loop. So if you go for lower level or lower fidelity devices, it's very complex to integrate them into an operational simulator. It's also difficult to modify, even if you're an OEM. I mean, you have a focal distance where the HMD is working with, and it's normally infinity. But in a simulator, you have a screen in front of you, and you have a different focal plane than the HMD has. So the optical modification is also super expensive. You want to avoid this. And it's bulky. It's like the device we've seen in the morning from Ian Sutherland with the CRT-based system. It's bulky, it's heavy. You see all the dimples on the helmet, which are used for the tracking. So if the cameras in the cockpit, and taking this all together, it's just not suited for being used in a simulator. So what could we do? We could use a simulation of the helmet, which means we project the HMD symbology onto the screen. But this, with pilots in the loop, they told us this is not representative and fidelity-wise not sufficient. And it stops where the screen stops. So if you look outside of the screen, you would have no symbology, but this is the main feature of the system. And if you look at the Eurofighter HMD, this is currently monocolor. If we want to develop stuff for next generation helmets, there is no system we can use currently for developing HMI or symbology for the system. So it's somewhat evident why not using a device like the HoloLens for doing that. And the approach was in this little case study to use it first as a replacement for existing HMDs and lower cost devices, and second, to use it for prototyping for future multicolor holographic HMDs, which will come into, let's say, next generation weapon systems, how we call it, maybe in 2035 or 2040. The results of this use case, I would say, summarizing, it's kind of mixed. Promising, but mixed. If you look at the results, if you look, this was too quick. So the lessons learned we have from it, I was actually, I was really surprised that the tracking works quite well. If you imagine a dome display, which is a diameter of 2.5 meters, having the pilot sitting in the dome, and having a lot of imagery, the environment you see in a simulator moving constantly, the tracking worked really well. I was surprised. I hadn't expected this. And the focal distance of the HoloLens matched quite well to the radius of the dome screen. This was a happy incident, so to say. The field of view, I mean, as we all know, it's not brilliant, but for the current HMDs we have, it's sufficient. They fit into the field of view of the HoloLens, but for future HMDs, I'm sure we will have a wider field of view, and of course need then to prototype this somehow, and we need a wider field of view than in the HoloLens. What was not so brilliant with the HoloLens, it's Wi-Fi only. I mean, with the trouble we're in a NATO secret environment, wireless networks are completely forbidden. I was never, there was a way of using the USB port to make Ethernet over USB, and this was somehow patched out of the system. And with that, we had to stop using it in the NATO secret environment. So from all what we did, we never tried it in the full-scale simulators we had. So this was really a pity. And second, we have the problem that we have stuff which is, let's say, related to the world space, and we have stuff which is head fixed, like a speed indicator, a altimeter, stuff like that. And if you have head fixed things, all the motion compensation of the HoloLens doesn't work anymore. So we had color separation, everything was visible 4 times. This was also a really problem, and the pilots hated it. Another thing was we wanted to stream sensor imagery from a turret, for example, for a camera into the helmet, and this also does not work to our needs. So one request, if someone is from Microsoft is here, I really would like to have a cable connectivity again somehow. I mean, that's really a problem for us. And it would also be nice if we could have 2 frame buffers somehow to have head-fixed content and world-fixed content that will be mixed in the display, but that we can have those two needs that we have combined in one system. And because of all this trouble, we missed till now to really look at what we wanted to look. I don't want to press sufficiently. So for the next steps will be to look to other hardware, like the Meta 2, which is wired and have some off-board rendering capabilities. And of course, we want to move from the things we have, this monocolor stuff, going to multicolor, going from lines to faces to polygons, going from 2D to 2.5D, let's say, that we have bands like shown in the image on the right side, but shaded, but still on a let's say projected onto the screen surface, and then later go to holographic content, to light fields maybe, which will be there in I don't know 10, 15 years when the aircraft will be built. And I'm really keen on using more GIS data in a system. I mean, imagine a situation where you're flying in complete fog and you do not see anything. Why not using all the GIS data we have? And Airbus is one of the biggest providers of GIS data, using it to do things like shown on the lower image on the right side, that have a virtual terrain, maybe enriched with additional metadata from OpenStreetMap or whatsoever. But making use of all this data we have in increasing the situational awareness of the pilots. And this brings me to the second use case. If we have a simulator and the pilots are wearing the HoloLens or a similar system, is there anything what we can do in addition for the simulators only, not for developing or using it for training? But is there a way of extending simulator capabilities we don't have currently? And they are. There's certain tasks which are really difficult to train in a simulator. For example, air-to-air refueling or landing on moving ship decks. And the problem is that there are features which are closer to the pilot than a screen. And though this kind of stereo vision is required for a successful air-to-air refueling, for example. So also here the idea is, why not using a mixed reality device and to render, in addition to the screen the pilot is seeing anyhow, only those parts of the system which are within the screen as a hologram, which means this would be the probe and the basket of the tanker. And as we started, I thought this is really a quick win, so to say. But it turned out that this is much more difficult than I thought. I thought it's easy and it would be coming for free, more or less. But okay, describing the problems here. You have the situation, a tanker aircraft, a fighter pilot wanting to refuel the aircraft, which is going like that. So you have the tanker with a hose and the Eurofighter coming. And now imagine the Eurofighter is a simulator with a screen. And you have the blue circle, which represents the basket of the system. The problem is in a curved screen in a simulator, the images have to be warped. They have to be transformed so that they make a image. But this works only for a designed eye point of the aircraft. If the pilot is starting moving his head, the image gets distorted. But our brain is brilliant by correcting this. But if I have something which is within the display system, which is in, like the basket in this case, I get an error. And so what suddenly happens is that if I move my head, the image gets distorted, and the basket loses this connection to the hose, which is super irritating. If the hose is somewhere, the hose is somewhere else than the basket. Another problem is if I have a wingman somewhere, and I want to, so if he's behind the screen, it's on the screen. If I want to move it to a hologram, which is, if it goes out of my visual, behind me, I want to look out, and suddenly there's a jump because now it's not 2.5 meters away, but maybe 400 meters away. So but this is a problem, but I think we can solve it quite easily by help. Could you press, I don't know, it doesn't work anymore. We can just shrink it and put it in the distance of the screen. So we could do the same with the hose of the tanker, but then you have a 40-meter long hologram, which starting in front of your nose, peeking through the screen, and going to the tanker. Where the same happens, then it disconnects from the tanker instead of from the basket. So the things we have to do is to really improve our understanding of those on-screen reality and the holograms. Because, I mean, the holograms are made to fit reality, but we have a projected reality on a screen, which differs from the real reality, so to say. And so we have really to understand what we could do and maybe derives from some strategies how we could solve this issue. By, for example, having the hose on the screen, but so that it stays connected, because one end of the hose is connected to the tracking information of the glasses. And of course, I have to look for students who do some prototyping work here. If we dare a outlook to the future, when mixed reality glasses will have an increased field of view of maybe 150 degrees, if we go up with the resolution to maybe 8K, so that we are close to eye resolution, and they're more comfortable to wear, there's a really huge opportunity to replace the dome display by a helmet, by the glasses. Because you wear it anyhow, and if you put all the content, all the outside, out the window view, as we say, by a mixed reality hologram, you would have a stereoscopic view everywhere, and you would save a lot of money. A dome of that size costs maybe $1 million US if you have 20, 25 projectors in it. And you can have a higher resolution system with a lot of more features, and you save not only the display system, but also the image generation behind. Because firing 25 projectors with images from the outside world, instead of having only one system which has to be driven, there's enormous potential for saving. That's what I'm dreaming of. Any questions? For the first question, we tried it, but the delay is to rewarp the image is a rather complex process, so you cannot do it in real time. It takes, if you recalibrate the image to a different eye point, it normally takes some minutes. So we have to use the tools the suppliers of the dome deliver to us, and so that's not. It would be a nice thing, but I think with the transport delay in the system, I think the pilot will get seasick very soon, very quick. That's what I mean. I think this is, you mean by a VR system? This could happen, but it's in a military aircraft, it's very, 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 very important to have tactile feedback, because in some switches and buttons in the cockpit, you just feel by the shape of the knob what you touch currently, so you operate blindly. And I think this will not work in virtual reality. You can use it for simple procedure trainer, for cockpit familiarization, for example, but not for a high-end simulator. For the consulting stuff, I think we have a own area within Airbus, which is called Holographic Academy, and they support us a lot with all those questions we have. And there's also a colleague of mine, he's talking on Friday around lunchtime, and he's also telling about this group within Airbus supporting others.
Okay, thank you very much. Thank you very much indeed. Thank you.
Welcome. Thanks.
Thank you.